Fantastic. Good evening. Welcome to Parcel B Campfire, the second in a monthly edition of Tech Talk and So What. That's what we're here to do tonight, connect with some Olin alums and learn about a topic. We're here at the grace of our hosts, Bloomberg Beta, here in downtown San Francisco. Thank you so much for hosting us. We have one representative from Bloomberg Beta joining us in the room. Thanks so much. My name is Bennett Shabbat. I'm a 2009 graduate of Olin College. Here hosting with a guest that we are very lucky to have, Audrey Lee, who I will introduce. I will attempt to do justice to her background in a moment. But first, want to thank you all for coming out on a weeknight. Thanks to everybody who's tuning in to the live stream. I hope the audio quality is fantastic. We have fantastic Bloomberg Beta people working on it. And thanks to my co-host, Maya Bittner, who has helped put this event together tonight. So tonight's talk is going to be a fireside chat. We're experimenting with what these campfire events work best, what form they work best in. So tonight we're going to try a one-on-one interview. I'm going to do my best Walter Cronkite. Audrey will be Teddy Roosevelt. I don't know if they ever actually spoke. Those are probably 20 years off. It's going to be great. It's going to be pretty informal, so we have an hour to chat, and I'll be asking Audrey questions. You can also ask Audrey questions. And if you want to jump in at any moment, just like raise your hand or stand up, and I'll throw you this. This is a microphone. And when you catch it, you'll be able to speak into it. Okay, so we'll demonstrate. So Maya's going to come up and tell us a little bit about our key host, Parcel B.
Hi guys, as you know, I'm Maya Bittner, class of 2011, and I'm here representing Parcel B, which is an angel group of Olin alumni who have pulled together their resources to invest in startups founded by Olin alumni. And there's a couple of different reasons why we're doing this. We're excited to support Olin students. We're bullish on the startups that they create. And we're also trying to build the brand and give them a leg up. Olin College alumni don't have the same reputation that someone from Stanford or MIT does, and so it's often harder for them to get early stage funding. And we hope to use the success of Olin alumni to help bridge that gap. Many of the startups that we've invested in are pretty technical, given the nature of Olin College. And in general, the alumni are very interested in technical topics, and so that's part of the reason that we're hosting these events, letting people learn about things that are in different areas than where their careers are, and hopefully kind of continuing some of the learning that we had at Olin. Back to you, Bennett.
I really hope you ask questions just so we get to do that. Yeah, maybe you finish your food and then we'll begin with the microphone throwing. Awesome. I am personally really excited to be here tonight because I work in this industry called energy. Turns out that's a big industry with a lot of parts and pieces to it. And tonight we're going to hear about the edges of the power system, what's going on with the power system, what's coming next for the power system, from the perspective of our very esteemed guest, Audrey Lee. Audrey is the Vice President of Grid Services at the solar installer SunRun. So that means right now she deploys and aggregates home solar and batteries to create a more affordable, clean, and reliable energy system. Audrey also serves on the Energy Storage Association Board. That's a national level industry group for energy storage technology, and on the NIST Smart Grid Advisory Committee. Previously, Audrey was VP of Analytics and Design at Advanced Microgrid Solutions, another awesome energy company, where she built the analytics and operations platform to optimize a 50 megawatt fleet of customer-sited batteries as a virtual power plant in Southern California after the closure of the San Onofre nuclear generating station. Huge win for...
I knew you were going to read it. I was sending you something shorter.
Well, suffice it to say, Audrey has a meteoric rise, I would say, in the fastest changing part of the power system, which is fundamental to, I would say, every other industry if it uses electricity. And tonight we're going to chat about what that means and some of the opportunities there. Thanks so much for being here, Audrey.
Thank you so much. Thank you to Parcel B and Olin College alumni, and you for inviting me, and Maya, and all of you for being here. Really excited for the discussion, and hope we get lots of questions and dialogue.
Totally.
See anything.
Well, first off, why are you working on solar?
That's a big question. I mean, it's so cool. It's clean. It's the technology is really exciting. I think there's so much potential, and we're just really at the beginning of the penetration of solar technology and what we can do with it, especially with the accessibility of energy storage matched with solar. I think that's what's really exciting for me. And being an engineer, the technology is really interesting. And then joining SunRun, where it's a residential homeowner customer. Before I was working on the commercial industrial side, understanding the customer value proposition and what is it that the customer wants. They want energy choices, and how do we provide that best product for them? I think is really fun.
Awesome, a very user engaged attitude.
Yeah, I think that's even more important on the residential side. And that market is just so wide open in terms of how we're at the very beginning of that in terms of penetration, and we could do so much more. There's so much more room for that.
Exciting. We hope we can cover more what this opportunity is and how big and exciting it is.
Yeah.
I'm really curious about how you made this transition from being an electrical engineer undergrad, research scientist, working in EE, doctoral studies at Princeton, with a thesis on X-ray fluorescence of heavy metals in plastics.
Wow, yes,
You
did research.
So just tell me about your adventure in now being an executive at a solar company.
I don't know, I started in high school, I was good at math, so I was like, oh, okay, I guess I'll study physics. Really liked quantum mechanics. I thought that was really interesting when I got to Caltech. And then after college, I didn't really know what to do. So it's like, oh, I guess I'll just go to grad school, which I think was a mistake. I should have taken a year off, found myself, become more enlightened. But I went to grad school in electrical engineering, started out in quantum dots. I was measuring electron spin lifetimes, and terribly depressed. I was in a dark room all day, aligning lasers with big magnets and liquid helium, and not interacting with the world, and not feeling like I was solving society's immediate problems.
Who can relate to aligning lasers? Okay, couple graduate students.
And it never worked. And I think I wasn't good at it because I wasn't passionate about it. And and that was why it was depressing. I was like, why can't I be good at this? And finally realized, well, I'm not passionate. I'm not interested in this. And I started exploring, I started talking to people, and started taking public policy courses, and just really loved that because I felt like it was more impactful to society. And back then, solar research was such a tiny part of it. It was more about semiconductors and how do we make faster computer chips. And so that societal impact, it was harder to find back then. And so I went into policy, but everyone said finish your PhD. That's going to be really valuable. And so I stuck it out, finished that PhD, and then I got a presidential management fellowship, which, if any of you are thinking about going back to grad school, it's a great program that the federal government has for graduate school graduates to go into the federal government if you're interested in exploring policy. So what was it? Am I answering your original question?
Yeah, definitely.
Okay.
I want to hear the whole adventure. So this brought you to the Department of Energy.
This brought me to the Department of Energy, and which was great because in grad school I was focused on this really this really narrow thing that 10 people in the world cared about. And I went to the Department of Energy, which is looking at the whole US and global energy system. And I think I really needed that after grad school to have that systems perspective. I always think if I could go back and do it again, I would do actually operations research. I think that solving system problems is really interesting to me. So that was great, and ended up working on linear programming, optimization, modeling of the U.S. energy system and globally. So that launched me into policy, but was able to still use my engineering background, which was great. And worked with national labs to do that. And then Should I keep going?
Yeah. So there was this trajectory from research science to policy. That's the big picture. Now you've trended back towards industry.
Yeah.
Does that feel like you're really making the thing and not talking about the
Yeah,
thing?
so it only took me 10 years to go back to technology after leaving it. So I went into, I'm from California originally, really wanted to come back. In DC at the time, it felt like it was hard to convince the whole country that climate change was happening and we needed to do something about it.
It's still true.
Yeah, and so coming back to California is like, oh, I don't have to explain that. We can just get started working on the problem. So I joined the California Public Utilities Commission and just loved how much of an impact I felt like, more impact I was making, and worked on a lot of the technologies that the areas that I'm working on now. So like demand response and energy storage, energy data, a lot of the stuff that they gave to the more technical person as opposed to the public policy people. And then being in government was a great place to have a good system view of what was going on in the industry. So at the Public Utilities Commission, I got to meet with the CEOs of different energy companies and got to understand this was the lay of the land in terms of the energy market. It came to a point where I felt like I needed more industry experience to be a good regulator. Like not having that industry experience, I didn't want to make bad policy, and felt like that was what I needed next in my career.
Thanks for that. As someone who's being regulated by the California Public Utilities Commission, I like that.
Yeah, and I wanted to understand the perspectives of different stakeholders in that process better. And so, coming from coming from policy and making the transition to industry was mixed. I think some people saw my background and thought, okay, you're in government, you must want to be in regulatory affairs. And I was like, no, I have this engineering background. I want to work on product, but I've never been a product manager. So people see that, I don't have that on my resume. And then other people are like, oh, you come from government, you must be really multifaceted and can handle anything and adapt. And so it was kind of 50-50 about, how people took my background and made that transition, and eventually found this company and founder, Susan Kennedy, at Advanced Microgrid Solutions, where we worked on commercial and industrial energy storage for grid services. So really, really appreciative of the opportunity that gave me to kind of go into industry and prove my product management capabilities from there. And then,
I understand at AMS you were there for a pretty key inflection point of growth for a new venture.
Yeah, since you guys are probably interested in startups, happy to talk about that. We started out with four people in our CEO's apartment, just down on 2nd Street, nearby here. And I joined before AMS had won a 50 megawatt contract with Southern California Edison, and you talked a little bit about in the intro, where I remember the San Onofre nuclear plant in Southern California closed. All of a sudden, there was a need for 2.2 gigawatts of capacity in the area. And you can't really build a power plant in the middle of LA. You can't really build transmission lines in the middle of LA to bring in renewable energy from the desert. And so, you need solutions that can work in an urban area like distributed energy resources. So like solar, like batteries, energy efficiency, demand response. And so there was this great opportunity, and I give props to Southern California Edison for having this they call it all-source RFO, where they didn't say, we want this much natural gas plant, we want this much energy efficiency, we want this much DR. They said, just bring us all your solutions, because we're not desperate, but we need solutions to solve this gap.
We're not going to say we're desperate. We're open.
We have this need for capacity. Bring us all your solutions, and we'll just put them all on the table and pick the best ones. And so that really gave the opportunity for something new, like behind-the-meter storage, to provide capacity in the way that a power plant could have. And so this, and this idea that you can take batteries that you install at customer sites, so large office buildings, water treatment plants, big box stores, this is what we did, university campuses, and you put them there and you provide a service for the customer by reducing their electricity bill, but then you can also aggregate them together like a virtual power plant. And it can be dispatched by the utility. So when the utility needs power, instead of turning on a power plant, they can call on a company like AMS or SunRun and say, hey, we need those batteries to start serving those customers so that they don't need to pull extra energy from the grid from a power plant. And so that was the business model at AMS.
I think this is a good segue to ground our audience who's here to learn something. They're technical people in how the heck the power system works. Do you mind giving us perhaps, a simple topic with, perhaps a 5-minute history of the power system with some highlights of who cares about distributed resources? How did we get here?
Yeah, so I think the history of it is a centralized system and now moving into a more distributed system. So, we had centralized power plants that produced electricity, and we built transmission lines that brought it into the city where a lot of population demand is, and distribution substations that then brought it down and brought it to the home, for example. And now we're seeing a much more diverse portfolio of resources where you have some centralized power, but customers like homeowners, SunRun customers, are producing electricity on their home, on their roof through solar panels. They can store it in their batteries and use it when they need it. And sometimes they export it back to their neighbor when their neighbor needs it. And so it's just much more dynamic. And I think, it's the equivalent of a more distributed infrastructure like Internet of Things, right? You have lots of devices, and like in the future, have them being able to talk intelligently to each other in a very automated way. And so we need to move the centralized command and control kind of infrastructure to a more dynamic one.
So the brains are moving out to the edges.
Yeah.
Or could.
It could, yeah. And I think it requires a lot of coordination between utilities, right, who are traditionally managed as regulators, energy markets, and then as well as the competitive markets where like solar providers like SunRun who compete with other solar companies as well, working together and coordinating. I think that's why grid services is so exciting, is that it's this opportunity for us all to work together to make all these assets work. I mean, my worst fear is customers buy solar panels and batteries. They buy batteries for backup. So if there's a grid outage, they can back up their home and still have power. So that battery sits there 99% of the time not being used because they're not in an outage situation. Whereas if there's grid services, they can use that battery to help the grid, to not have to turn on that power plant or not to spend money upgrading a substation. So we want to make use of all those assets. I think of it as like the sharing economy, right? You don't want underutilization of assets of this capital that's been put down.
I agree. We have a question.
No one saw that. Quick question for the group: how would you define grid services? How would you break that down?
I would define it as there's different products in the grid, and I think it can get really confusing. I think a simple way to think of it is energy and capacity, but even that is an old paradigm, is a paradigm that comes from the centralized generation, right? Like a power plant has a certain capacity, certain power it can provide, and the energy is the amount of kilowatt hours it provides based on the fuel that it has, based on the fuel that you put into it to generate electricity. But within that construct, you can think of grid services as offering capacity and energy as kind of the main thing. So if the whole California independent system operator, the whole California system has a duck curve. Are you guys familiar with the duck curve? So yeah, okay. So the system needs capacity in the early evening when the sun goes down. And so could you have all the batteries, for example, that are deployed start discharging in that time period to serve that load? And I've called that a grid service. But there's more simpler constructs like time of use, right? So time of use periods where there's on-peak power windows and off-peak power windows, where for the duck curve, when that need is in the early evening, is an on-peak period, sending that market signal and responding to that with a battery and a solar panel, I would say, is a service to the grid as well. And then I think you can get further down, there's ancillary grid services like reserves and frequency regulation. There are autonomous grid services like you can have smart inverters that can help correct the frequency of the grid or correct the voltage on the grid as well. Does that answer your question?
That's great.
But it's still really undefined, right? How do these distributed energy resources contribute grid services? And I think we're all in this period of trying it out in a safe and reliable way.
Thanks for that. I would just ask to clarify before this next question. So like there's a key difference, and these are totally different services or products, useful objects, both the power, like the immediate ability to meet demand, watts, versus the actual commodity, the units of energy they might actually use. So those are like two different things that are useful in different ways.
Yeah, although as a physicist, they're the same to me. There's just a time element.
Except for the time, yeah.
And the time element of it. And that's why I'm wondering, like, is it a construct of a power plant that we're still attached to this capacity versus energy? And I think that's what we struggle with in the market creation and policy context of, now that we have these different technologies, how do we think of it, right? Like storage has power and has energy, but it has to be charged, right? It's not infinite. It's not like you just keep feeding it natural gas and it keeps producing energy. And so how do we, and these are the kind of debates that are happening in public utilities commissions and at the FERC, the Federal Energy Regulatory Commission, about like, how do you create these new market constructs for new technologies? And I think it's a very exciting time to think about what's possible, what you can do with these technologies.
I want to go to the question in the back. Nice.
So with regards to advanced microgrid services, I was curious, so you won the 50 megawatt contract, and it sounded like you resolved that issue, or your solution was to create a bunch of energy storage networks in the city. But what was generating power? Was it solar? Were you aggregating excess power during off-peak times? What was the solution?
Yeah, so in that particular case, because it was, some of the customers, for example, were Class A office buildings that were like 20 stories high. So there wasn't a lot of space for solar. So these were batteries that were being grid charged. Whereas you could be at a university where they do have a solar array and it could be solar charged. But you're charging the battery during off-peak hours when the grid has excess power. And then you're dispatching it when the utility calls on you. So there's a contract that between AMS and the utility, but the idea of the grid service here is that utility says, oh, I need power, sends a signal to the aggregator, and then the aggregator discharges the battery.
Just follow up on that. So I think kind of disconnecting this idea from capacity storage or energy, were you able to fulfill a 50 megawatt contract but not actually generate 50 megawatts of power?
No, there was you really had to provide it.
Okay, great.
Yeah. So there's this concept of being paid for capacity every month for being there, and then when you're called on, you deliver it and dispatch it. So if the utility never called you in that month, you'd still get paid for that capacity because you were there ready to serve it. And then so sometimes these contracts have a capacity payment and an energy payment. So you get that capacity payment every month, and then if they call you 20 times, then you could get some energy payment for each of those calls in addition.
Again, paid separately from the instantaneous ability to deliver power versus the actual energy that you moved somewhere. Alley-oop? No? Okay, yep. We could have handed it, but it's fun to throw.
So you briefly mentioned it's exciting to work on this new model of how to compensate all these different services, but big utilities are sort of stuck in this old rate case model where it's going to take 5+ years to have a new rate case. In the meantime, they're going to keep on building the distribution network because they have cost of capital recovery. And so they're incentivized to overbuild the system. You guys have these flexible things that can be switched on and off, and where you need to structure markets much more dynamically. What would your ideal regulatory system work for or look like to be able to really incentivize innovation here, where it's not going to take 5 years to clear the red tape for a startup to get off the ground?
So I'm very excited about things like in California there's a proceeding called the Integrated Distributed Energy Resource proceeding, where and in New York you have some similar structures where there's an incentive for the utility to deploy distributed energy resource. So in this case for the IDER projects, the utilities identify a substation that would need to be upgraded. So say you have a new home development and you have all of a sudden this demand for electricity in this area, and you have to upgrade the substation to serve that need. well, instead of upgrading the substation, there could be a lower cost alternative to deploy all those homes, to deploy solar and storage on all those homes, and then you don't need to upgrade that substation. And so this proceeding, you're probably familiar, that gives the utility a 4.5% return, I believe, on those contracts. So there's an incentive where the utility can earn a rate of return on this contract, even though it's not a capital investment in the substation. Because you're right, the utility would be in the current construct incentivized to just upgrade that substation and earn a return on that. But here, they're incentivized to have a contract with DER provider to do that. So I'm excited, but they're in the first stages, right? So the utilities have proposed one of these, and so I get it. It's hard. It is hard for a startup to navigate in this
scalable business model.
To build a scalable business, and I think that's the reality. Is it's hard to work with utilities because they're conservative for a good reason, right? To ensure the safety and reliability of the grid, and so it's just a longer business process to do that. And I think that's why it's good to have more of a diversified customer, right? So like at SunRun, like there's the utility customer for good services, but there's this existing homeowner customer that continues that supports the business day to day until we get to those new constructs. It's tough.
Yeah, that's wondering. For people who don't know, I'm that utility guy. I work at Pacific Gas and Electric, the utility, so relate very much to that.
Please chime in on your perspective.
Maybe it's useful to clarify that, like, the way that utilities are conservative by design, that you don't want people taking risky stuff, 10x but likely to fail kinds of investment risks with whether or not your lights will work tonight. Agreed? Yeah, we kind of want them to work. So there's a lot of structures that like reinforce that conservatism. It then becomes a cultural value, which I don't agree with. But one of the key ones is that like basically how the utilities were built out is like when load goes up, more homes are built, et cetera. We need more power flow out. We need to upsize the lines, et cetera. The utility is allowed to build new capital assets. That's what the utility does. Wires, transformers, poles, in order to meet that load. And on a pretty slow recurring cycle, we say we built this much stuff to meet this much new load. And in order to guarantee that people want to invest in that happening, investor-owned private utilities like PG&E, my company, then get a fixed rate of return. So they're guaranteed to get a certain return back on that capital investment. Municipal utilities are like funded by their city or county government.
And I guess I'd just add, the perspective from AMS was, when I was there, was don't try to offer a product that requires a rule change, a regulatory rule change, because that can take a long time, right? Work with what you can. I don't think AMS would have launched without that utility contract. And so, there was no scaling of AMS until AMS won that utility contract. Having that was what allowed it to be project financed. And you had asked about what it was like to be at a startup, and that was a lot of that. Negotiating the contract, raising the project finance, going through due diligence with independent engineers to make that happen.
May bring us back to how the grid works. I'm curious, just like if I had 1,000 blenders and I turn it on, what's happening today, and like how do people know what to do, and what are they actually doing when I turn on 1,000 blenders? What would happen if nobody did anything, and what do you want to see the world doing in the future?
I would love for you to answer this both in the context of current generation and in a totally turbineless environment.
This suggestion was in the context of current generation technologies and in one without turbines, gas-fired turbines.
Yeah, I think I would love to hear your answer on how, I think you have a good perspective on that.
Thank you, Audrey.
I'm just going to throw the question back to you.
Yeah, no, I'll take the questions you don't want. That's fine. We're going to be here to serve you. We're your utility. So the fact of the matter is, when you turn on those 1,000 blenders, somebody turns up a power plant. Somebody looks at a screen, a human says, that power plant should turn up. And that literally happens. That there's a big system of a lot of power plants. They're predicting that this is going to occur. So it's planned in advance. But generally speaking, these power plants are ordered to come on so that like as those blenders all come on, somebody responds and the power instantaneously moves there. There's no storage in the system between.
How do they know? Like, what do they look at? Just voltage drops?
So some of these things are fairly predictable, like that everybody likes to make their smoothies either in the morning or at, when they come home for dinner. So it's like, we know we're gonna have these plants ready for morning smoothie and evening smoothie. So they have that schedule.
Yeah, and I think there's I guess there's different pieces of it. So I got to visit this SCE, Southern California Edison control room, and like your blenders at your home at the end of the distribution line may cause a voltage drop, and so they may see that. So the distribution company, like SCE, may see that, and they say, okay, well, I've got to put more reactive, or I can't remember which way, add or inject or absorb some reactive power, and I have these controlled, these capacitor banks that can do that to take care of that. So I think there's that distribution side of it, and then the kind of how does it flow up? Does it get absorbed by the solar panels that are generating in your neighbor? Right, that solar, they're exporting, and so they're serving your power, and so it kind of nets out there rather than kind of trickles back up to the system level. It's complicated.
Maybe I could add one more major framing of the system architecture that's useful. So that there are two very distinct domains that have different key control signals. In the transmission domain, the system, it's all a gigantic AC circuit, but in the transmission domain, which is high voltage, like tens of kilovolts to hundreds of kilovolts, as that's the voltage in the gigantic power lines. So that's a looped network. So this circuit connects like amongst, quote, all power plants with relatively few offshoots, meaning there's a lot of different ways power can flow, and chiefly governed to frequency. So frequency is held at like constant value. There's all these systems in place to make sure frequency is at 60 hertz. And if frequency drops below 60 hertz, you don't have enough generation. It means like load is dragging down the sine wave that's moving around on the AC circuit. So that's one thing that you would see. So they're constantly looking at frequency. There are various means to respond. When you move across a transformer into a low voltage that we call distribution, now this, instead of being like a big loop where power plants can sort of feed anything on that loop, from that substation point, it's radial. So that means from that point down, it's seen as just like a one-directional power flow out of the loop. So there's like a big loop, and then there's these little branches of a tree coming off, feeding the leaves.
That's like generally more California, and like when you go to like New York, it's a little bit more networked, is my understanding. So I think that's a good overview, and then there can be variations.
And voltage is a good reference of like on that system, you always have a drop in voltage from like the point from the substation to the end. And again, we have like a fixed target that we're trying to hit there. So you got to make sure that voltage is in range. If the blenders turn on, voltage will drop, and we manage to voltage. And like maybe you have to boost it from at some point down from the source to the last sink.
Right. And so what's exciting about distributed energy resources, then solar and storage, is with smart inverters, you can automatically sense the voltage and adjust for it autonomously with your battery. You could. There's a lot, and this, utilities they've deployed smart meters to do this to measure the voltage all along the line, but you can also do that with the inverters and the meters that get put in. And so that goes back to what we were talking about earlier about having these devices being able to talk to each other to solve these problems when the 1,000 blenders turn on, rather than having the person at the power plant, moving things up and down.
Now all of a sudden it's really different that you have a device on the end that not only can produce power, where that was only ever a sink for 100 years, that end of the line has been unidirectionally taking power, but it also can sense what's going on with the power quality. It's also looking at voltage and can do things to maybe react to that. That's where the root of these grid services could come from. Oh, please, yeah.
This might be a dumb question, but are the turbines within steam power generation, are they literally spinning 60 times a second to keep the frequency at 60 hertz?
Yeah, so there's a rotor and there's the... I don't...
They also have a gearbox.
Yeah. Okay. Got it. So probably not.
I'm not a power system engineer, and I wish I was.
Something is.
Something is
some
somewhere.
part of the...
And that's that. And my understanding is that, just to be honest, I think I know what I'm talking about. Just the inertia that has as a physical system kind of helps keep it at 60 hertz as well. And so there's people talk about like synthetic inertia with a battery where it doesn't have something spinning, and how does it keep that 60 hertz?
So if 1,000 blenders are turned on and the frequency drops, the turbines slow down. They physically slow down.
And thus injecting their kinetic energy into the system, providing this first order control.
Microphone.
So as the turbines slow down, there's automatically energy injected into the system, kinetic energy transformed into electrical energy. So there's that first order control happens instantaneously. And with like solar and distributed resources, we have to automatically like code that into
Set it in the setting.
these devices, rather than having that be something that just happens through physics.
So I think that discussion, okay, we'll take another one.
Well, yeah.
Okay, well, yeah.
I mean, thank you. But also, I'm going to shift it back to this very exciting like evolution in the technology that's allowed DERs, distributed energy resources, to proliferate. So with any advance in technology, generally there are winners and losers resulting from that shift. And I'm curious, from your perspective, how would you rank order the biggest beneficiaries of this evolution in the industry? And under what conditions or in what scenarios does everyone win, including the utility?
So I think a winner, and this is maybe my bias coming from SunRun, I think a winner is customers, like customers having more choice and not just taking the energy that's fed to them from a centralized place, and the cost coming down, and being able to reduce the cost of energy for customers. What was the second part?
Under what conditions or what scenarios does everyone win, including utilities, developers, customers, society?
Yeah, I think if we can reduce the costs of the system, we can share those savings and everyone wins. And I think, for the utilities, it's coming up with the right regulatory structures to incentivize and pass on those savings, share those savings with customers. So for example, if it costs $10 million to upgrade a substation and you can do it with $5 million of DERs instead, then there's $5 million of savings between the 5 and the 10. So we can all share those savings and everyone wins that way.
Audrey, one of Olin's core principles is user-centered design, thinking about what people care about, what they want. Seems like you're pretty tuned into that as well. So I've heard a factoid, I think even from PG&E's own like customer engagement group, that they're working with an attention span to the whole issue of energy, which is very small. That like people think, I'm probably misquoted, so something like people think about their energy bill for single-digit minutes in a year, something like that.
Right.
So customer choice on one hand sounds really appealing. On the other hand, are there challenges or do a lot of people feel this way or like care about choosing where their energy comes from? And how deep does that choice go? What gets people emotionally engaged with this kind of product?
Yeah, I mean, I think we've seen with our customer, we've seen with the rise in adoption of solar and storage. I think that's an indication of customer excitement and the growth towards that. But you're right. I think that, and that's why there's such high customer, and that's what surprised me coming into the residential solar market, the customer acquisition costs, right, to get their attention, right? It's not a simple thing to put solar panels on someone's roof and drill holes into it and require, all these inspections to do that. And so, like, how do we make that even easier for customers? I mean, it's surprising to me in a way, like, you're offering the customer something that will save them money. They're not paying extra for it. And so, like, why wouldn't someone do that? But there's a lot of attention span that's required from the customer to do that. And so that's something that we're really working on. Like, how do you continue? And I think that's the exciting thing about technology is how do you continue to add further value, right? So with the battery, we can add backup capability. And so it's more than just saving 20% on your bill every month. It's about, I had an outage the other day and I was in the dark for 10 hours and that was really painful. And so layering on these other values, I think, is really important for customers. So it's more than just saving on your electricity bill, which is kind of boring, but providing these other features. I think that's what's exciting for me.
Right. I think energy storage is exciting, but I may be in the minority. Why are we only hearing about energy storage in the last few years? Is this new? Like, this is a core technology question. Like, what's the deal with energy storage and why is it new?
I think it's the costs have come down, and that's what's exciting. It's much more accessible now, and I think you're seeing more market structures that incentivize it. So, for example, take California and time of use rates being default in California. That has helped also with the economics. We're seeing 20% over the last year, 20% adoption rates in California, and in some markets we're seeing 60% adoption rates. So that means that 60% of all our solar customers are also buying storage. Okay. Does that make sense?
Yeah, 60% of solar customers.
60% of solar customers
also want a battery.
Also want battery. We see, and there's no reason why that can't even go higher. But I think it's not quite a commodity the way that solar panels are. It's more complex because it's not just produce electricity. You have to figure out how to control it. You have to tell it when to charge, when to discharge, and so it's not quite mature there, which is exciting for me because I think there's further cost declines that can come with that. There's a burning question there, I think.
Catch box. Oh.
Well, actually, my first question was going to be what percentage of SunRun's new customers are opting for solar plus storage, and so thank you for answering that.
It's 100% in Hawaii.
Okay,
and
yeah.
And we just launched, approximately 100%, we just launched in Massachusetts and New York as a backup product.
Okay.
Of all the winter storms that they have and hurricanes.
So in Massachusetts and New York, is the storage part of the solar plus storage not grid tied? Is it just for home backup, or do Massachusetts and New York have like demand response, like residential demand response programs?
Yes, they do, and
Okay.
it's part of my job to make sure that happens. That we can
Okay.
that utilities can utilize those batteries for demand response programs.
Okay. And my other question is sort of related to that is, so I know that there's it's sort of like an ongoing fight between homeowners and utilities about net metering. Like a lot of states want to either cap or shut down their net metering programs. Net metering, by the way, is when you get paid to put electricity back onto the grid. I'm wondering in states where they're thinking about either capping or shutting down new net metering, if the batteries attached to home systems can still be used for grid services, and if homeowners can get paid for grid services even if net metering is like not an option anymore.
Yeah, so I will answer your question, but I want to say that there's net metering sort of 1.0, which was flat tiered rates where you get paid for the export, and I think a good model is California's net metering 2.0 model, which is that you get net metering, but it's on a time of use rate. So you get, when you're exporting, you get paid a higher rate during the on-peak period when that power is more valuable. And if you're exporting during the off-peak rate, you get paid less. So, and in California, that on-peak rate keeps shifting to the evening because there's so much solar, right? So if you just have a solar panel, then you are getting paid at the mid-peak or off-peak rate for the most part. But if you put batteries on, and this is why the adoption rate for batteries is so great in California, is then you can reduce your consumption of more expensive on-peak power and export. So we think that's a really good model to get the most out of solar by putting people on time of use. So I say there's a difference in NEM when you talk about NEM and the verse version in a second. And then in terms of, sorry.
It was that even if a state shuts down its net metering program, will a state continue to reimburse homeowners for the batteries that they're providing?
Yeah, so I think one thing that's interesting that's developing is Hawaii has this, HECO introduced this GSPA, Grid Services Program Agreement, I think. But anyway, it's a program to do grid services, and a lot of the customers in Hawaii they don't have net metering, so they can't export, or they don't get compensated for export. So it'll be interesting to see how that program plays out to do grid services in that kind of environment that you're talking about.
Yes, love the engagement. Thank you. You can throw it near or far. Good luck. Beautiful.
Sure. I'm sure SunRun must be very happy about the recent announcement from the California Energy Commission that all new homes of certain sizes must have solar panels by 2020. So they estimate something like 14% growth domestically, or at least California, do that for solar panels. And it seems like there's a very compelling case for having storage combined with that. What is SunRun doing in terms of just maybe packaging or just making it a default configuration for those customers, those developers or individual homeowners, to just have storage as part of the package that they buy from SunRun?
For new homes.
New homes, yes.
Yeah, so we got a lot of attention in the press on the new homes announcement and talked about it in our last earnings call. But that's definitely an area that we've been working on, that we've been talking with new homes developers and working with them to do that. I mean, it's great because it can reduce the costs a lot of the problems with putting in solar and putting in batteries is all the different homes are different. Your electrical panels are different. You may need main panel upgrades. Your roof may need to be repaired before you can put the solar panels on. And so the new home opportunity is great because you can reduce the costs and make sure that those homes are solar ready and you can immediately put solar on. And so we are working on partnerships with new home developers to do that. And that comes in 2020, so there will be a ramp to that.
And my follow-up was, because it is a new home opportunity, are there certain ways that a provider like you could be influencing like architectural decisions, locations of batteries now that you are basically part of the design process? And what do those look like? I'm frankly curious because I've talked to some companies just about like, how do you put in solar for like a condo building, and they automatically just kind of glaze over a little bit if they're not a good sales rep, and then say it's very complicated in some ways. And that's usually not very encouraging, but obviously for new homeowners, it's going to be, a brave new world. That, there's going to be more design options to think about.
Yeah, no, I think that's exciting. And I think as a former policy wonk, that's what's exciting about regulations that do help that do help bring down the costs, right? By not being overly regulatory, but like having a regulation that helps bring down the costs, that helps society. And so in terms of specifics, we generally install batteries in the garage. In terms of putting on solar panels, the amount of offset you need, the obstructions, like if you have different vents in your roof, that can limit how you lay out the panels. And so it's a great opportunity to work more collaboratively with builders to make the homes more solar and battery compatible.
Moving back to this man in the front row, we have another question.
So we haven't really talked about the low carbon nature of distributed grids. And I live in SF, and one of the cool things with SF is we have two different choices for 100% clean energy. So you can buy it from the city and get wind for $5 extra a month, or you can buy it from PG&E and get solar for like an extra $5 a month. But that's only about half my energy utilization. I still use a lot of natural gas. And I think most of the homes in San Francisco have water heaters and furnaces. And I'm wondering, like, as you look at the new grid, are we looking at moving all these natural gas appliances and into electric appliances? And like, is there startups building electric appliances? I mean, I've gone and looked at electric water heaters and they kind of suck. And like an electric furnace doesn't really seem to exist.
There's heat pumps, air source and ground source heat pumps. But yeah, that's definitely an interesting area. And I know I was having a conversation with someone at NYSERDA, talking about electrification and fuel switching. And for us, it's interesting, if there is the ability to put more solar panels, that incremental cost is quite low. And so electrifying more of the home and serving more of it with solar can be very, very economic. In terms of startups doing that, I can share some of the ones we're looking at to do that. And I think, especially you talk about natural gas, which I think eventually because it is carbon emitting, we'll need to switch over to electricity. But I mean, the low-hanging fruit is fuel oil. Like when I lived in Boston, like people still get fuel oil delivered by truck to heat their homes, and that is more carbon intensive and costly. And so that's a great opportunity to transfer people over to electric heat pumps.
One other aspect of that is that as soon as those appliances are electrified, then they could be controllable, right? All of a sudden they could be part of a responsive load profile of a home that mixed with a battery, like maybe I put energy in the battery, maybe I heat up my water a little extra, and it'll stay warm for a few hours. Are you looking at those sorts of controllable loads?
Yeah, so I think that, I can't say that SunRun is there yet, but I think that's part of our vision, and we introduced something called the Brilliant Home, which has all this control. So, it starts with solar and batteries, but moves on to, thermostats and pool pump controls and water heater controls and electric heat pump control to control more things. So I think you're exactly right, and it's very exciting. And how does that merge with the connected home and Internet of Things, and how these devices communicate within your home? And I think SunRun's in a great position because we have this 20-year relationship. We have for our lease customers, we have a 20-year PPA, power purchase agreement. So we have this 20-year relationship with the customer where we can be there, and that's why my group is called Energy Services. We can be that energy as a service provider, not just a solar panel seller, as we go forward.
I want to talk more about what's going to happen in the next 20 years and how these people should get involved in the next 20 years. So I'm curious if you could paint any view of some of the opportunities in this space from your perspective. One of them could be core enabling technologies or gaps you see in the market that need somebody smart to come hack on them.
Yeah, and I think I touched on this before, is really getting out, really being more curious about what's possible and new paradigms. And I think it sounds like you guys come from that, where you're thinking about just because we did it this way doesn't mean we need to, and we need to do it the same way. And I think that kind of plays out in technology and what does that technology do? What's the functionality of that technology? But also regulatory, like why do we have the rules the way we have them, and how do we change them to take advantage of all the functionality that we're getting from technology? And in the utility, I mean, I think the group that you're part of, the Grid Innovation Group, is a really important part of that. What other facets?
Well, I'm curious, you led a big energy data initiative at the California Public Utilities Commission. Are there any data scientists in the room? Anyone who would perhaps empathize with that view of the world?
Right?
Yeah. So what are there opportunities in that space? Who cares about energy data, and what's it worth? To who?
I can speak to, like at AMS, I had a data science team that would look at commercial industrial energy usage and figure out ways to use the battery to help them reduce their electricity, reduce those costs. And so the data science was the optimization modeling and linear programming that we did to optimize what the battery did. It's funny that I actually used the linear programming I learned at the Department of Energy and applied it to the optimization program at AMS. I never expected that I would be able to transfer that skill to build that optimization platform. And so in that data science, it's so multidisciplinary, because as a data scientist there, you had to understand the tariffs, you had to understand the policies, you had to understand all the different utility programs, and then you had to understand the technology and what it could do. You had to understand power system engineering and how it interacted with the grid. So it was just a really fun and dynamic group where we solved these really interesting problems. And then at SunRun, I also have a data science group there on my team that looks at grid services potential, right? Modeling how do we take this fleet and predict how we're going to use it to serve a utility need. But also data science at SunRun is, we have 180,000 customers right now so far. And so we have a network operations center where we're monitoring all these solar and battery assets. And so, looking at that data and thinking about how can we improve the production? How can we, constantly improve what we're doing, reduce the costs of maintaining the systems, reduce truck rolls. I mean, those are some of the applications that we're looking at. And I think there need, doing data science, doing the data proceeding at PUC, I found that I struggled with communicating the value of data there, and I think there's just a need. There weren't that many. There's a need to have more technical capability in policy, and I saw that at the Department of Energy when interacting with Congress. You see that at the Public Utilities Commission as well. That there's a great value for having an engineering background and understanding quantitative stuff.
Could I take a stab at like why data is important and you can validate
Yeah,
it? I'll
please.
be like, no, that's crazy. That if we're moving to a world that has many more sources of generation, more controllability, is basically becoming astronomically more complex to make the biggest machine in the world, the electric power system, work. And so there's relatively more value and challenge in just deciding what to do when, and like understanding how to operate all these.
Yeah, because if the vision is that it's all automated, you have to start with a prototype of what that automation looks like, right? You need to think about, it's like how I think about data scientists are, they look at problems, they solve those problems one-off, but that one-off solution becomes a prototype, which goes into production and becomes part of the system. Like that's the process I see. And so there's a very important role if we want to get to that future of all this data. And I would love to hear PG&E perspective on the data that you're getting from smart meters and from different sensors on the grid and what you do with that and what's data science at PG&E?
It's also nascent. So from my group, Grid Innovation, I would say it's a lot of the early implementation of what use cases should we even go after. Like there's so much operational information about all the pieces of this complicated system, so many pieces of hardware, assets that have existed for 20 or 30 years that you want to know everything about, but making sense of it needs to be, especially when it comes to distributed resources, people are trying to understand what's going to be valuable. Like which of these grid services do we need? And our team specifically is trying to build what I think of as the utility side system that would need to reach out and connect with the solar and batteries in order to say, hey, we need you now. Right. Like voltage is low, can you help me out? Right. Like this is the time, do your thing. Because even just to be aware of that, you would have to be pulling in like meter data. There's lots of other line sensors or devices around that are measuring things. But knowing what needs to be looked at and having the capability to pull that together, make meaningful sense out of it, to ask for new tools to solve the problem. Like we're at that core platform development piece now, and pretty early in that journey now. And PG&E's like pretty well advanced in, or like of utilities in the world. It's like thinking about this more than people who are in different regulatory environments that haven't pushed them in some of these directions.
So I have a dream. I have a dream that we will all share this data, because I think what's important about data is when we can all share it and layer it on top of each other, we see things that you don't see when you're just looking at your data. And that grid data about the grid from the utility can be shared, and data from providers like SunRun can be shared, and so we can see what's going on. And you make it open so that the market can come up with a solution, right? That utility may not have all the answers, SunRun as one company may not have all the answers, but you put it out there in a safe way, such that the market can find creative solutions to this. And so that's my dream. I think like the distribution resource planning proceeding that the California PUC had, where the utilities published information about their hosting capacity and locational net benefits, and mapped out their circuits, and like I think San Diego Gas and Electric, we wrote a white paper on this, showed hourly minimum and maximums at every distribution substation. That's very powerful. And then the market can say, oh, you have this need at the substation. Well, what if we put DERs here and here and configured them this way? Right, together we can come up with really good solutions.
I have maybe one more question. We just have another couple of minutes, but there are a bunch of founders or would-be founders in the room. What would you say to a prospective entrepreneur entering this space, working at the grid edge?
I am in admiration. Seeing the founder at AMS, the founders at AMS, and how determined and visionary they are, really inspires me. I don't know if I have it in me. I was employee number one, so I kind of borderline, not quite founder.
That's pretty close. I feel like you might have some advice.
Yeah. I think it's hard to imagine. It was very hard. I never would have imagined where we would be 3 years from when we started. Like what was just like a concept, I mean, that was the amazing journey. Like what was just a concept actually became a reality that actually worked, right? The technology platform we built is actually being dispatched by Southern California Edison today at batteries, and nothing's blown up. Knock on wood. That was the most amazing experience for me, and it was constantly, from our CEO Susan Kennedy, failure's not an option, right? We're going to succeed in this, and that faith and blind. And it's hard for me as an engineer because I'm super analytical. I'm like, yeah, but there's these risks, and I'm quantifying these risks. But what's so inspirational is the sheer determination that really did, help us succeed. That didn't let us fail.
Thanks for that.
So keep going.
Awesome. Well, we'll have more time to chat after this offline without our internet friends. Thanks for joining, internet friends, tuning into this live stream. We'll have it recorded as well for your post-hoc viewing pleasure. For those in the room, please join me in thanking Audrey for joining us. Thank you so much. It was really great. And tune in hopefully next month for another Parcel B Campfire. Thanks so much for coming out.